Hello dear students, in today's class, let us learn about the physics of forced harmonic oscillations. We will try to understand about the behavior of forced harmonic oscillators and we will try to obtain the differential equation corresponding to the forced harmonic oscillator. So I hope that you already know about natural oscillations or simply the simple harmonic oscillations. So in these oscillations, there is no external force that is being applied. The restoring force that is acting on the body is the reason why the body executes the simple harmonic motion. So the restoring force is the only force that is acting on a simple harmonic oscillating body. While in the case of forced harmonic oscillations, we will be additionally applying an external force that will have a specific time period or frequency. So for example of a forced harmonic oscillator is a forced swing. So if a person is sitting on the swing and swinging naturally, then that comes under simple harmonic motion. But when somebody else is there to push this person at certain frequency, then we call such kind of oscillations as forced harmonic oscillations. Here this external agent is applying an external force, say F or F0, and that frequency and force is driving this naturally oscillating system. So in a forced harmonic oscillator, the oscillator is compelled to oscillate with a frequency other than its natural frequency. The natural frequency is the frequency with which the system will oscillate if there is no external force. So that will be the frequency of a simple harmonic motion. But when we apply an external force additionally to the system is set to oscillate at certain other frequency. Another example is the spring and mass system with a hand driving this system. Earlier we considered the simple case of a mass suspended from a spring end. Here the system will simply execute oscillations up and down. But when a hand is used to make the system oscillate at a certain frequency, we call that a forced harmonic oscillator, and the external force applies a driving frequency into the system. The system will have a natural frequency, but we are additionally applying another force, and the system is forced to oscillate at another frequency, which is the driving frequency. Now let us try to understand what are the forces that is acting on the system on a forced harmonic oscillator. First of all, since it is an oscillating system, a harmonic oscillator, surely there must be a restoring force. I hope you already know about the expression for a restoring force. The restoring force should be proportional to minus Cx. This is the nature of a restoring force. It is proportional to minus x. C is the constant. And if the system is under some sort of damping, there will be a damping force. And the damping force is proportional to minus gamma v or velocity. So which is equal to minus gamma into dx by dt. Now thirdly, since this is a forced harmonic oscillator, there should be some additional force, which is the externally applied periodic force. External periodic force. And that force, F, can be written to be equal to F0 sine pt. So this is an externally applied force which is applied periodically. F0 is its amplitude and P is the angular frequency of the externally applied force. Or we could say P by 2 pi is the frequency of this externally applied force. External force. So in the case of the oscillating system like this swing, The restoring force is due to the natural oscillations of the system. The damping force is due to the air and other frictional force within the swing. Maybe here we will have a latch and that will have some friction. And this friction and air resistance are the main cause of damping force. The restoring force comes mainly due to the gravitational force that is acting towards the mean position. In the case of a simple pendulum, we have seen that there is this restoring force that primarily arises due to gravitational force. The system will execute oscillations. And the external force is the driving force applied by this external person. So these are the three forces in the case of this swing. So I hope that the concept of these three forces is clear for you. Restoring force is the natural frequency, is the reason for the natural frequency. Damping force is due to the other external elements that causes damping within the system. And the external periodic force is the force that we apply externally to drive the system. So with these three forces in our mind, let us try to formulate an equation corresponding to the motion of a forced harmonic oscillator. So we can write that the total force acting on the system is minus Cx minus gamma into dx by dt plus F0 sin pt. The summation of the three forces is the total force acting on the system. These three forces. Now from the Newton's second law of motion, F is equal to m into d square x by dt square, which is the equation F equal to ma. Now equating 1 and 2, we can write the equation of motion, the differential equation corresponding to a forced harmonic oscillator as m into d square x by dt square is equal to minus Cx minus gamma into dx by dt plus F0 sin pt. Here we can make a small change to this equation, a modification to this equation. So let me rewrite d square x by dt square is equal to minus c by m into x minus gamma by m into dx by dt plus F0 by m into sin pt, where I have divided the terms with m throughout the equation. Now bringing some terms to the left hand side, we would get d square x by dt square plus c by m into x plus gamma by m into dx by dt is equal to F0 by m into sin pt. Now, we have already made some substitutions, like we already know c by m is equal to omega 0 square, where omega 0 is the natural frequency, angular frequency, and gamma by m is 2k, k is the damping constant, and F0 by m can be chosen to be small f0. And modifying the above equation, we may write d square x by dt square plus, let me write this term second, 2k into dx by dt plus omega 0 square into x is equal to F0 sin pt. So this is a differential equation corresponding to the forced harmonic oscillator. Solving this differential equation will give you the idea about the motion of a forced harmonic oscillator. So you might have already seen similar differential equations. Earlier there was a 0 here on the right hand side in the case of a damped harmonic oscillator. Now we have another term here, and we will have to solve this differential equation in order to find the behavior of a forced harmonic oscillator. So this is the differential equation corresponding to a forced harmonic oscillator. Within this equation, a lot of idea is contained regarding the frequency and the behavior of the system. So in the next class, we will try to solve this differential equation in order to find an equation for x, from which we will be able to analyze the behavior of the system. I hope this portion is clear for you. Thank you.